Even and odd functions. Now this follows a little bit from a previous video that I made over symmetry. So if you need to, hopefully I remember to provide the link so you can look at what symmetry is. Now even functions, that's actually the same thing as having y-axis symmetry, and odd is the same as the origin. Now I'll go ahead and do a little review. Over the y-axis means you're going from a positive x to a negative x. Origin means you're going from a positive x, or actually we're going from a positive xy, going over 2 quadrants to a negative x, negative y. So what that means is both of these, or in other words, if I were to label this point, it would look like this. So if xy is a point in the first quadrant and it's an even, that means negative x comma y is also a point on the function. If positive x comma y is a point on the function and so is negative x comma negative y, then it's odd. So if you take a look at both of these, we have x going from a positive to a negative in both of them. The y only does it for one, but the x changes for both even and odd. So that's your test. We're going to find f of negative x. And when we find f of negative x and do the algebra, if it turns out that the y's stay the same, then it's even, or if they're equal. So if you have equal results from what you started with, it's even. Now, if we take the x, replace the negative x, x to negative x, and the y changes from a positive y to a negative y, that means it's odd. So if you have the opposite of what you began with, it's odd. So keep that in mind. The whole test is f of negative x. When you find f of negative x, if you get the same thing back, which is equal to what you started with, then it's even. If it's the opposite, then it's odd. That's all it means. So let's do some examples. F of x equals x squared plus 2. The test is to find negative x. And by the way, one thing I needed to mention, there's nothing for over the x-axis because we're dealing with functions. And if it's symmetrical over the x-axis, kind of like this, that's not a function. That doesn't pass the vertical line test. That's why we only have two options, over the y-axis or the origin. In other words, only even and odd. There's no third case unless it's a neither. So let's go back to our example. We're going to just do f of negative x in all these examples. We're going to replace the x with the negative x. Make sure you use parentheses. And then if you take negative x and square it, or negative times a negative is a positive, and you get x squared plus 2. Is that not equal to what we started with? Notice what I said. Equal. Since it is, that means it's even. E-E. Now let's do this one. B part. F of negative x. Everywhere you have an x, replace it with a negative x. So when I cube a negative, that's negative stays. And then negative 2 times a negative x is a positive 2x. So let's look at this for a second. We went from an x cubed to a negative x cubed. Those are opposites. We went from a negative 2x to a positive 2x. Those are opposites. Since they're opposites, this is an odd function. Opposite just means all the signs are going to change. Let's do this one. Once again, our test is only f of negative x. And once again, all I'm going to do is rewrite it. We're replacing all the x's with negatives. And let's do the work. We take a negative and raise it to an even power. It becomes a positive. Take a negative, raise it to odd. It stays a negative. So I still have x to the fourth. Negative times a negative is a positive x plus 4. Now, is that the same thing as what we started with? No, because of that middle sign, so it's not even. Is this the opposite of this? No, because the opposite of x to the fourth minus x cubed plus 4 would be negative x to the fourth plus x cubed minus 4, which this one definitely isn't. Since it's neither even or odd, we call it a neither. And before I do that example, I want to show you something with the calculator. It doesn't always work as well as it could because of the restrictions on the domain of the calculator, but it can be really good. Watch this. I'm going to define x, I'm going to graph x squared plus 2. This is something you want to see in the textbook anywhere. So my test is I'm going to replace x with negative values. So right now I have x, if I choose x equals 2, I have y equals 6. Now I'm going to hit, by the way, I hit trace, in case you're wondering. I just hit 2, enter. My trace key is still active, so I don't have to hit trace again. So I got 2, 6. If I hit negative 2, look what I'm going to get. Positive 6 also. If I hit 3, I get positive 11. If I hit negative 3, I get positive 11 also. What that means is I'm replacing the x with the negative x, or 3 with the negative 3, and I'm going to get the exact same y value. The exact same or the equal. Even. Did you catch that? Rewind the video if you didn't catch it. To the next one. X to the third. Oh, my bad. It's a minus. Minus 2x. So I'm going to hit the trace key. Let's just hit 1. Enter. We get negative 1. Now I'm going to hit negative 1. And we get positive 1. Did you catch that? Let's hit 2. We get 4. This time I hit negative 2. And I got negative 4. When I replace the 2 with the negative 2, I got the opposite y value. See, 3 gives us value of 21. For it to be odd, when I type in negative 3, I should get the opposite of 21, which is negative 21. See that? A little trick there. Now this one, the one that's in neither, let's see what happens. You paid $100 or more for this calculator, you might as well use it. But hopefully it doesn't do too much, because then it'll be banned. So we have x to the fourth minus x cubed plus 4. So I'm going to hit the trace key. I'm going to hit 1. It doesn't matter what I pick, but I got to stay between 10 and negative 10. If I hit 1, I get 4. Now if I hit negative 1, for it to be even, I better get the equal 4 back. For it to be odd, I better get the opposite, which is negative 4. And let's see what happens. Negative 1. Let me do this one again. It's messing me up. 1, enter, gives us 4. Negative 1, enter, gives us 6. I didn't even get the same value. I don't have to do anything else. I know to neither. What do you think about that? Little tricks. Which you may only get from me. Who knows? Now this is another example you may see. I kind of like these examples. It's a different kind of example. You're given 3, negative 5, and you have to find a point on the graph that's even, another one that's odd. So here we have 3, negative 5. Now for it to be even, that means that we're going to replace the x with a negative x, or even is the same as over the y-axis. So for the even point, or using the even information, everything tells you we're going to replace the x with the negative x. We're going to get the same y value, or same thing as saying reflected over the y-axis. We're just going to put it at negative 3, negative 5. Now odd means that we replace the 3 with the negative 3. We're going to get the opposite of the y value, in this case the negative 5. Or in other words, it's going to be 2 quadrants. I have to go this way so we don't get confused. 1, 2. So that point looks a lot like negative 3, positive 5. So keep that in mind. Remember, we're still replacing, for even now, replacing the x with the negative x. So 3 becomes a negative. Even, the y value stays the same. Odd becomes the opposite. And that's all that example is. And we are done.